Hello everyone, and welcome to IMSC 685 MIS. Today we're going to talk about Introduction to Logistic Regression. Um, let's talk about what is the logistic regression. We're going to, this lecture, we're going to learn about uh, using logistic regression as a method for classification. Some of the applications for logistic regression, including determining the spam email or the ham emails. Many of the spam filters and the email clients are using this type of algorithm. Um, Second is this so-called for the bank to give out the loan, they determine if this loan is going to be default or not and calculate the risk. In what condition and the loan has a risk for default. And the third type of application, including like a disease diagnosis and determine a person with a certain medical condition has a possibility to get pneumonia or cancer or not. And these type of applications so far is a binary. And later on, later lecture, we will focus on talking about multiple class classification problem as well. Um, so far in the machine learning aspect of the lecture we're talking about regression problems where we're trying to predict a so-called continuous value. Those problems are fairly important in real world. However, a big class of application we have is using to classify, for example, in your marketing research, and you're trying to group a certain type of customer and will buy a particular interesting in your one category of a product or different type of product in certain region and different season, and they could have purchased particular type of product. And all these type of detection or learning process we need to use in classification. Although the name for logistic regression, it looks like fairly confusing in the beginning. Um, However, the logistic regression is allowed to solve the classification problem that linear regression cannot handle. Okay, so these are the things we handle, so-called categorical data. Okay, so conventional we have binary classifications to have two classes, 0 and 1. So basically yes or no problem. Um, Look at the data we have, for example, and is the age of the patient or the possibility has a heart defect, a possibility. And so these type of problems, if we're using linear regression, is you see on here we have a so-called probability of 1, yes, they have a heart defect. Okay. Second is 0 is they don't have. If we solve these type of problems using linear regression, we probably have a very bad regression line. Even we have a probability below 0 in that case. So this type of thing may not be very convincing. However, using logistic regression, and we're using these type of curve line, and we can fit certain point age that will have more possibility to have a heart defect or certain age below, we may not have those type of issues. So this is logistic regression using this may be a better fit for categorical data. We call it classification problem. Okay. For using this curve, and this type of curve we generally refer as a sigmoid function. The sigmoid function is start from the 0 all the way up to 1, so it's perfectly fit for probability of something happen. And we can scale it and shift it in the way so we can have much better, wider application for categorical. So yes or no, yes, we go to this category, no, and we typically have regions which between 0 to 2 positive, plus or minus 2 have some kind of fuzzy situations right here. And we talk about those, how do we handle that as well, okay? And the Sigmoid function is basically, we can take a linear regression solution and place it into a Sigmoid function. So originally we have a y equals to b naught plus b1 times x, which is a linear model, which is the red line over here. But we can convert it into logistics model and determine the probability of certain things happen or certain outcomes going to happen or not. Okay, and typically we can set like the cutoff point as 0.5. If anything below this result will be classified as class 0, and anything above that we can classify it as so-called class of 1. So we can set any type of cutoff point. Generally we're using 0.5, and also for other application we can scale this to maybe -1 to 1 and using 0 as the cutoff point, and many applications would do that as well. So but general Sigmoid function looks like this, okay, 1 over 1 plus exponential of a negative z. The z is between negative infinity to positive infinity. And we can also scale the shape of this logistic curve, and by putting some multiplication factor onto it. So the logistic regression function or sigmoid function is a very flexible function to determine categorical data, and we show you how to use that. The general trend for using logistic regression is we're first going to using a set of data, a part of the data, to train the logistic regression model on some training data set. Then after that you evaluate a model, perform some type of prediction using a test data set. So initially what we're trying to do is we take our data, split it into a test training set and the test set. So the training set we're going to use for training our logistic regression model, and then we're using the test set to validate if the model is good enough, okay? And we can using a so-called confusion matrix to evaluate the classification model we come up with in the logistic regression. So here we're giving you example how the evaluation goes. For example, here we have, I'm trying to test for disease, a certain type of disease, and the confusion matrix looks like the following. And total right now we have 100. We have 165 data points, and and we have actual yes or no problem, and maybe we have 50 of predicted no, and actual is no. We have 50 correctly. They have no disease, and predict is no. And also we have 100 of the samples actually has the disease, and prediction is also say yes. But we have 5 of them actually the patient has a disease, but the prediction say you don't have that disease. And this type of situation we call it negative. Okay, so also we have 10 patients actually have no disease, but the prediction, the model says it has certain type of they have identified they have the disease. Let's take a look how we usually call these convention. First, we talk about some terminology, and if Actually, the patient has a disease, and with prediction is also yes, and these we call the true positive, okay, case. If the patient has no disease and also the prediction model also predict say have no disease, and we call it true negative. If the patient has no disease and but we predict it as has a disease, and this we call the false positive. This is usually referred in statistics as a type 1 error. The other type of error could happen is actually the patient has a disease, but the model said it has no disease. It tests negative, and these we call a false negative. And this is usually in statistics we refer as type 2 error. How are we going to measure the accuracy of a model based on the confusion matrix? And basically we'll say the accuracy of the model equals to the true positive plus the true negative divided by total number of tests we have, which is in here is 150, 100 plus 50 divided by total 165, and as probably 91% of the case. Okay. All right. The next we're talking about the misclassification rates, usually measured by overall how often our model is wrong, which is wrong. In this case, we're taking the false positive. Okay. False positive, actually no, we say it's yes, you have the disease, or actually you have the disease and model predict you don't have it. And so the false positive plus the false negative, and see how much of the percentage is that. So in our case, we have 10 plus 5 divided by 165 is about 9%. The other one we're talking about the alpha and beta, and alpha represents the possibility of type 1 error happens, and beta represents the possibility of type 2 error happens. Okay. The confusion matrix basically says the false positive, meaning if you trying to test for pregnancy and you telling a man, they say you are pregnant. So these are the things we usually use to in our education for the student to remember this type of scenario. You kind of remember what is the so-called type 1 error, what is the false positive. So this is the slide people usually put up, and for student to remember what is the type 1 error and type 2 error. The type 2 error usually means actually you're telling a pregnant woman, say, hey, you are not pregnant. So these two type of error happens in many type of models, or later on we're going to continue use these type of concept for many of the machine learning algorithms and even neural network, and for classification problems we're using as a measurements for that. So after this, we're going to start talking about using Python to perform the logistic regression. Except we're going to be using the famous Titanic data set to attempt to predict whether or not a passenger survived based off their specific features, usually the age, the classes of the cabinet they are in, their genders, and other features in the passenger database, and to determine what is the likelihood the passenger will survive. Is a good exercise. Then we have a small homework assignment on the advertising data, trying to predict whether or not a customer will actually click on a online ad. So I'm going to conclude this section of the theoretical discussion of a logistic regression. We don't put any type of equation here. I'm just showing you the concept, we will have much more technical information in the next lecture period. Okay.